The main focus for today is something called electron configurations. Okay, an electron, what's it mean? What's a configuration mean? What's that word mean? Kind of. Configure means to change, but a configuration tells us kind of the arrangement of something. How it's configured tells us kind of where these things are located. Okay, so the electron configuration is going to tell us where can we find these electrons in every element. Okay, and the Bohr model gives us a good 2D picture for most elements. The electron configuration gives us an exact kind of location for every electron in our element. Okay, a semi-exact. Okay, so electron configuration is the arrangement of electrons in an atom. Okay, where are these electrons located? How many are on each energy level? Things like that. Okay, so it takes the Bohr model and it takes it up a notch. Okay. Okay, like most things in nature, electrons want to assume the lowest possible energy, which means, just like when we drew our Bohr model, you have to fill all the lower energies first. So all the shells closest to the nucleus have to be filled before you can fill outer shells. Okay, that's all that's saying. Your electrons have to be filled from lowest energy to highest energy. So closest to the nucleus, and then you can start moving out. Okay, these are called ground state electron configurations, which means we're not looking at elements or atoms with charges. We're not looking at anything extra. We're just looking at elements in their stable, neutral state. Okay, and we're going to learn how to do ground state electron configurations for every element. Okay, and there's just very simple patterns that we follow that our periodic table really helps us out with. Where these are colored, you need to kind of just indicate this on your periodic table. And if you'd like to color your periodic table, you can. If you'd like to just look at it, you can. But groups 1 and 2 right here are called the S block. Okay, so that's the S block. Okay, and there's 2 groups that are found in the S blocks, groups 1 and 2. If you skip over here to group 13, 13 through 18 is what we call the P block. The transition metals are the D block, and the lanthanides and the actinides are the F block. Okay, so we need to label those on our periodic table. You don't need to label the ones or anything yet. I just want you to know that this whole part of it is the S block, and helium fits in the S block as well. Okay, see how helium right here is part of the S? Then these 6 groups, are part of the P block. The transition metals are part of the D block, and these lanthanides and actinides are the F block. Helium's part of the S block. You don't have to, you can move it over there if you want, but it's part of the first level. Okay? And then if you haven't already, it might be helpful for you to label your rows on the periodic table, right? 1, 2, 3, 4, 5, 6, and 7, right? If you haven't done that yet, it might be helpful for you to look at that now. Don't worry about these guys just yet. We'll talk about those, and these guys just yet. We'll talk about it here in a second. The number corresponds with the row of the periodic table that we're in, right? The 1S block is in the first row. 2S is in the second row. 3S, 4S, right? All of those are exactly how they should be. But what happens when we get to the D block? Why don't the 3 and 4 right? The 3D orbitals are shifted down one spot on the periodic table, right? One row on the periodic table. Okay? And that's just with how those elements fit in. But what happens with these D block elements is that when we said in Bohr's model, when we get to the 3rd energy level, we can hold more than 8 electrons. So that's what's happening with this D group of elements. They can hold more than 8 electrons, but where they fit into their outer shell can hold more than 8 electrons, but where they fit in on the periodic table is a little bit lower. So the same thing happens with the F block of elements, right? The F block really fits in right here and here, but it's not 6F and 7F, it's 4 and 5. Okay, so let me show you what these letters mean a little bit more. Okay? Okay. So these letters and what everything is alluding to at this point, the S block, the P block, the D block, these are shapes of our orbitals, okay? And orbitals are little pockets that hold electrons. Okay, so you might want to write that down. An orbital is a pocket that holds an electron. Okay, and the letters that we put on our periodic table, those are the shapes of these pockets that hold electrons. Okay, so in the S block on the periodic table, the electrons are going into an S-shaped orbital, which is a circle, a spherical-shaped orbital. Okay, so if we're looking at a first electron, like for hydrogen, right, it's only got one electron, and that element's in the S block. So that one electron is going into an S orbital, a spherical-shaped orbital. Okay. The P orbitals are dumbbell-shaped like this. Okay, the P orbitals are dumbbell-shaped. Okay. So in the P block, the S orbitals are full, and now we move on to the P orbitals. Okay, and if all of our P orbitals were full, it would look more like this. Okay, so let's take a look at our periodic table. In the S block, or the S orbitals, right, if this is full, how many electrons can it hold? Right here, like let's say 2s. Okay, second row, S block. How many can that hold? Just 2 electrons. So the rule for an orbital, any orbital, can only hold 2 electrons. Okay, any orbital can only hold 2 electrons. So, if we look at the P block on our periodic table, how many spots are there to fill? 1, 2, 3, 4, 5, 6, right? So if each of those orbitals can only hold 2 electrons, and we need to house 6 electrons in the P block, how many of those do we need? 3. Okay, so let's think about this. This is one P orbital. This together, right, 1, 2, this can hold 2 electrons. Okay, we could also have a P orbital that looks like this, right? That could hold 2 more electrons. We could also have an orbital that looks like this, right? That could hold 2 more electrons. So that right here would be what a full P orbital looks like. It can hold 6 total electrons. I want you to walk away with right now. Okay, orbitals themselves can hold 2 electrons. These are shapes of electron pockets, basically. Okay? So as we start filling out these electron configurations and as we start looking at putting in our electrons, we have to fill the lowest energy first, right? That's saying if we want to look at nitrogen's electrons, we have to make sure all of these are filled up before we can get to nitrogen. Okay? So this is the order we have to fill our levels in. And you don't have to write this down just yet. I'm just walking you through it. We fill our 1s orbital, which is hydrogen and helium, right? Then we would move on and we fill the 2s orbital. So what elements are found in the 2s block on your periodic table? Perfect. 2s block. Okay, that's where we should be right now. Okay? In the 2p block, what elements are found in the 2p block? Boron, carbon, oxygen, fluorine, and neon, right? All of those are found in the 2p block. So if I were to ask you, what block is bromine found in, right? Search for bromine, and you're going to tell me what block is it in. Bromine is number 35. 1, 2, 3, 4, and it's in the P block. Perfect. 4p. Okay? Are we doing okay with locating those electrons or locating those elements right now? Yeah. Okay, what about manganese, which is Mn, number 25? What would that be in? Mn, number 25. 3D. The 3D, good. Remember the d orbitals are shifted up, one row. 3D, okay? That's okay, it's okay. We're going to get there. Okay, I just want you to recognize where they're at on the periodic table right now. Okay? And if I asked you for, let's say, cesium, which is CS, number 55, what block on the periodic table would that be found in? 6S, right? 6S, right? Because we're in row 6, 1, 2, 3, 4, 5, 6, and it's group 1, which means it's in the S block. Okay. That's right. The D block is shifted up 1 row. Okay? And the F block, these guys down here, right? Usually they would be 6 and 7, but they're really 4 and 5. So they're shifted up 2. Okay? I'm going to give you a little sheet that will help you follow along the order that you have to go in.
Wait, these are 4 and 5?
4 and 5.
Okay, so these are 4.
Look, I'm going to give you a sheet to show you what order our electrons have to be filled in. So if you can't quite follow it on the periodic table, that's okay. I'm going to give you something else that will show you which order our electrons have to be filled in. Okay? So this is what our little pathway looks like. Okay, so I might need to make more copies of this. So right now, just share with your partner if you need to, and I can make more copies later. Okay? So our pathway. This is how electron orbitals need to be filled. Just share for right now. I'll make more copies in a little bit. Okay? So, I want you to look at the relationship between this pathway and your periodic table. So this is saying as we're putting electrons into their spots, we have to fill the lowest energy level first, which is 1s. Okay? So the 1s orbitals are hydrogen and helium. Are we on the same page there? So on your pathway, maybe, right, it says we have to fill the 1s orbitals first. Then you follow your line. Next, we have to fill the 2s orbitals. Okay? Which means we would move right down to lithium, beryllium. Okay, are we on the same page so far? What would we fill next? What do you think we would fill next as we're filling in our electrons? 2p, right? And we follow our line, and that's what we get, to 2p orbitals. Next, we would go to 3s, okay? So we go 3s, and then we just move right across our periodic table to go to 3p. Okay, so as we're filling in our electrons, they have to follow the order. After 3p, we just move right down, right? We're adding another energy level to our model, and we're at the 4s. Then we fill 3d orbitals. Okay, so we're following along that our pathway shows us the exact order that we should fill, just like our periodic table does. Okay? Okay, so I want you to look right here, just for right now. Just right here for right now. Okay? I don't want this to be overwhelming. Okay, just look at hydrogen. Okay? Just hydrogen for right now. How many electrons does hydrogen have? 1. And it's found in what block? The 1s block. So that's hydrogen's electron configuration. 1s1. That's it. Right? It's saying that hydrogen's 1 electron, which is this guy right here, is found in the 1s block. That's it. Okay? So now if we look at helium, helium has 2 electrons. Okay? And helium is found in what block on the periodic table? It's in the 1s, and it has 2 electrons. Right? So that's it. Okay, let's try and move down a little bit further here. Let's look at boron now. Okay, so I'm not going to let you see it. Okay, boron. Where is boron found on the periodic table? 2. The 2p. Okay, so that means to get to 2p, you should follow along on your pathway, right? The 1s orbitals, are they full? Yes, they have to be, right? They have to be. 2 electrons can fit in that orbital. The 2s orbitals, are they full? Yes, right? They have to be, right? In order to get to boron to move along, they have to be full. So we said that boron was in the 2p block. What element is it in the 2p block? Number 1. Within that block, it's the first element. right? So one of its electrons is found in that 2p block, right? Its last electron is found in the 2p block. So now what we're doing is we're going to check ourselves. 2 plus 2 plus 1 gives us 5 electrons. Is that how many electrons boron should have? Yes. Okay, how are we feeling now? A little bit better?
But if I did it, I wouldn't be right.
Let's tell me first of all, which block is fluorine in? It ends up in the 2p. Okay? Fluorine ends up in the 2p, so we have to fill all of our orbitals before 2p. So if you follow along on your pathway, in order to get to 2p, you have to go to 1s, 2s, 2p. Okay? The 1s orbitals, are they full? Yes, so that's where the 2 comes from. 2s can hold 2 electrons. So in the 2p block, how many electrons is fluorine using? 5. Okay, fluorine's the 5th element, so that means 5 of its electrons are in that 2p orbital. Okay.
Same for like boron, carbon, nitrogen, oxygen.
Those are all 2p block. Yep, but boron would only have 2p1. Carbon would be 2p2, right? Nitrogen would be 2p3, right? So this part looks the same up until that point.
So with like the 5 is because they're all 2p, so there's 5 of them.
The 5 is telling us that 5 of fluorine's electrons are found in the 2p block. So yeah, since we had to move over 5 elements to get there. So once you think you have it done, you need to add up your superscripts to make sure your electrons match. Okay, if they don't match, something went wrong.
What is that line thing?
That's how I abbreviate electrons with an E minus. Okay, so that just means electrons.
So we're gonna have to do that on
No, that's just what we're doing to check ourselves. Okay, you don't have to do that. I'm just showing you. We should have 12 electrons because it's a neutral magnesium atom, and we do have 12 electrons. Okay, what other questions do we have? How are we feeling? Better? You ready to try these on your own? Let's do just potassium. Don't do calcium. Do potassium and silicon. Okay, potassium and silicon. Try those. Okay, so there was our final answers. Let's try now copper. copper. Cu. Mm-hmm. Okay, so it's important here that 3D doesn't just get paired with the 3s, right? The 4D orbital is technically filled, the 4s orbital is technically filled before the 3D is, okay? So yeah, it is a little bit weird, but that's just how it goes. Okay, so do we all have that?
No. Yeah. So will we be allowed to write on our periodic table during the quiz?
Mm-mm.
I don't like that. Are we? Oh, well, that's actually easy. So just what am I saying? 6. That would be 4, 5. This would be 6, right? We got it. Oh, Jane. Got it.
Is it Can we have more like those on the
Okay, what do you think? Say it in one time. 1, 2, 3. Krypton. Good. Good, good. After 4P, where would I go? 5S. Then what comes after that?
4D.
4D. So if I did 4D6, what element is that? If I kept going and I went to 4D6, what element is it? This is all one configuration. I'm not starting over.
It's not supposed to be complicated. I'm just like
Ruthenium, yes.